Hello. Let's get on with lesson 117. All right, so here we're going to be talking about the different letters that we're going to use to designate the different sets. All right, so we've already used the R for reals in class. So we're just going to add a few letters to our set. So we can use W for whole numbers, the N for natural or counting numbers. We're going to use a Z for integers. Q for rational numbers. We're going to use a P for irrational numbers. And a C for complex numbers. All right, so using these designations for numbers and sets, we're going to write our equations a little bit differently. I forgot one. So we also have reals on a 2D plane. That basically means just like with X and Y. All right. So we have the set builder notation. So we're going to say that A is the set in which X is a subset of, we're going to say integers for this one, such that, it's going to be a long vertical line, X plus 2 is greater than 4. Alright, so this is just going to mean it's the same thing as saying X plus 2 greater than 4. Domain is integers. This is probably a more concise way of writing this information, so we're going to use this now. Alright, lesson 117 was pretty short in content, so we're going to go straight on to lesson 118, which is logarithmic equations. So, we've talked about logs before, so we're just going to go through some logarithmic realities, equations, that are going to help us solve problems in the future. So if we say the log of 7x equals the log of 7y, it's the same as writing 7x equals 7y, so x equals y. All right? So we're also going to write things like this. Log of 10, 5 plus log of 10, 7. All right, so when we add logs, we're going to multiply the arguments. All right. So we can solve things a little more complicated as well, like this. It's important to note that this only works if you have the same base in the different logarithms. So what about when we subtract the logs? If we have something like this, we're going to end up with a division. Just like that. All right, and what if we have a coefficient to our logarithmic equation? So this 4 is going to be the exponent to the argument. So we're going to write it, or another way to write it is going to be like this. So if, for example, that is a variable, depending on where we need said variable, we can write it here or here. All right, so let's do an example. Here we have the log of 3 is x plus 7 plus the log of 3, 2 equals the log of 3, 20. All right, so like we talked about just here, the logarithms are being added. So we're going to multiply them like so. Right, and like we talked about previously, if we have the same argument and the same base, we can say that the arguments are equal. So therefore, we can solve for x.